Right, so in this video here I'm going to explain what hexadecimal is, why we use it, and how to convert to decimal, convert to hexadecimal from decimal, and convert to binary from hexadecimal. So why do we use hexadecimal? Well, the reason is this. It's an easy way to represent 4 bits of information. So as you can see here, this is the system we use with 10 digits, 0 to 9. But if we only use them and a single digit, we can only go up to number 9 with 4 bits. But 4 bits can actually go up to number 15. So when people were trying to show binary back in the day, before, they would either have to write 8 zeros and 1s, but they wanted a way that they could write it much simpler. So someone invented hexadecimal, and it allows you to represent 2 bytes with just 2 digits. So like F6 could represent, 1 whole byte of information. The first letter, F, would be 1111, so that's the left, so that would actually be this in binary. We're going to go through this in more detail later. And then the 6 would be 0110. So that was representing that number in binary, and it's a lot simpler. Now people could say, why don't you just write 15, yeah, and then 6. But the problem is here, is that 56, is it 1, 5, and then 6? Is it a 1, a 5, and a 6? So this could even be, this could be 001 for the 1, it could be 0101 for the 5, and it could be 0110 for the 6, so we don't know. So the whole point was with hexadecimal was to keep it so they were nearly always drawn in pairs, like this. So you use them in pairs, and then they can represent 1 byte with just 2 digits. So even if the first digit is 0000, and you would, so you don't normally write 07 for 7, but in binary you would. In a hexadecimal, sorry, you would, because that way you 100% know that represents 1 byte of information. So they're always used in pairs. They're basically just an easier way to show a byte. Anyway, so how do I convert from 5F into our number system? Well, this is our number system here. For 2 digits, we have a units column. Going back to primary school here. We have a units column worth 1, and we have a tens column worth 10. Now, because we have a 10-digit system, when you go to the left, this multiplies by 10. And then when you go to the left again, it multiplies by 10. So the next column's worth 100, and so on and so forth. Okay, that's our number system. So that's 76. Now 7 times 10 for 70, plus 6 times 1 is 6. That would be 76. So hexadecimal works similar, but with their number system. And because their number system has 16 digits, then it's multiplied by 16 each time it goes over to left. So you always start on 1. This is times 16. And this would be times 16 again, which would be 256. But like I say, they're only ever used in pairs, and you won't get that in the exam. So don't worry about carrying on. They're always just used in pairs like this. So 1 and 16. So how does it work? Well, let's take the one we've got here, 5F. I'll line them up in a sec. Right. So 5 times 16. So quick math tells me that's 50 plus 30. So that's 80. Okay, so 5 times 16 is 80. And then this column's always just worth what it is. And F times 1, and F, as you can see down here, is 15. So that's 15. So we add those together. And so this number would be 95. Okay, so it's 5 times 16 plus 15, because 15 is F. So let's try the next one. The next one is B4 on the list. So we'll do B4. So we don't always need to draw out the column, so we know it's B times 16 and then plus 4, because the second one's only worth 1. So this column's, the left column's times 16, the right column's just worth itself. So B times 16, well, B is 11, so 176, because 10 times 16, 160, plus 16. And then obviously 4 is just 4 times 1. I mean, I suppose you could put the times 1 if you wanted, but it's kind of pointless because we all know that times in 1 doesn't do anything. So there we go. So hopefully you can work out the answer there. It'd be 180. So I'm going to do one more, and then I'm going to get you to do the rest of the sheet while I pause the video. So last one is AA. Okay, so that's A times 16. A times 1, if you really want to do that. I'm going to line these up because I'm fussy. So A is 10. This is the easiest one of all. A is 10, so 10 times 16 is 160. 10 times 1 is 10. and then that ends up being 170. So that's AA. So just remember that the left column's times 16 and the right column's just worth itself. It's just the same as our math system. A lot of students really struggle with this, but personally I think it just makes common sense. You know that ours is 10 times because we have 10 digits. This one is 16 times because they have 16 digits. And even though it doesn't go up to 16, which a lot of kids get confused by, neither does ours. Ours stops at 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You use 2 digits for 10. Okay, it's called a 10-digit system, not because it goes up to 10, because it has 10 digits, because you're forgetting to include naught. And just the same as this one, it has 16 digits, but it starts at naught, so the highest number is worth 15. Before you need to use a second digit. To represent 16, well, that's one of the questions later, so I'm not going to go through that. So, pause the video now, and then go on to do the rest of the D, E, F, G, and H on the sheet, converting to decimal. Right, now we're going to convert to hexadecimal. This is slightly more difficult because you have to do more mathematics, and let's hope I don't make a mistake. So the first one is 55. So basically, you have to find out how many times 16 goes into 55. So essentially, it's 55 divided by 16. And then whatever the remainder is will be the second column. Okay, now, I know that you might want to, if you really want to, do your 16 times table out like this. Because that's really going to help you. You know. I'm just going to do to there because that's all we need for this one. So as you can see here, the closest I can get to that without going over is 3. So that means the first digit is 3. Okay, so this is worth 16. So this one here, this column is worth 1, we haven't put this in yet. This column is worth 16, so that's worth 48. That leaves me with 7. Okay, so then I just stick the 7 in there. And that's what you do. So that one would be 37 in hexadecimal. Okay, let's try a different number. I'm going to leave up the times table, but I might have to add more to it when I see it. But this one's 127, so we're going to need more numbers. Okay, 127. I'm going to do, I don't know if I'll actually get it in there. So 5 times 16, you should know, is going to be 80. Because you should know. 6 times 16, 96. And then we're going to get to the one we want. 7 times 16, so to add 10, 106, add 10, that's 112. Okay, so I know that after this, I can go to, sorry, it's not to my door. Right, so 7 times 16 is 112. So I know that if I add another 16, I'm going to get 128, which is over this. So I can do it if you want, just to put it there. But I know I'm going to go over that because I didn't. So that's my times table. If you're doing the real one, you might write the whole times table out. I mean, it's not that difficult. So now I know that the first digit is going to be 7. So that's 7, because that was worth 16. And that's worth 112. That leaves me with 15 left. So 15 in hexadecimal is an F. So I'll put the F there. So that would be 7F. Okay. I could do the last one. It's quite an easy one. It's 45. So 45. So that's the highest number that goes into it. So it's 2. And then I'm left with 13 to get to there. I look for 13. And that's D. Done. Bang. So 2 times 16 is 32. Plus 13 is 45. There we go, 2D. Now, I'm going to stop the video. You could do the last D, E, F, G, and H, and then I'm going to do the last one, which actually is quite easy. Right, so, don't do this anymore. Now, the last one is to convert to binary. Now, I've left this because there's actually 2 ways of doing this. You can just do 5F, which you should know now is 5 times is 95, because we did that earlier. So 5 times 16 is 80 plus 15. So you should know that that's 95. So the one way to do it is to convert it to decimal and then just do the binary. I don't know which way I'd do it actually. I'll probably do both. I'll probably just do it one way and check the other way. Okay, so because I can quite easily write 95 in binary, and I'm confident that 5 times 16 is 80, and then F is 15, so 80 plus 15 is 95. So I kind of would do it this way, but I would probably check it the other way. The other way is just to do it as two individual numbers. So you've got 5 and F. So the first 4 bits will be 5. So I'm not going to look at the book on the right over here because I want to do the math. I'm literally not going to look. So I know that 5 in binary is 0101. Okay? Because this column's worth 1, this is worth 2, this is worth 4. If you don't know that, then you need to be revising my binary videos and binary worksheets. So that's my 5, okay? I also know that F is 15. I know that F is the highest number in hexadecimal, and I know it represents 4 bits. So F is always going to be 1111, okay? But F is 15, and 4 bits 15. So that is actually going to be 95. Anyway, now that's easier to do in theory, as long as you know 5 is 0101. You know, as long as you know these characters. You could learn this list, but it seems pointless because these are quite easy to convert. You could then check it if you want. So obviously this is worth 1, 2, 4, 8, 16 and 64. So we've got a 64 there. Here. 1, 2, 4, 8, 16, 32. So we've got a 16, an 8, a 4, a 2 and a 1. So that's a 16 there. So that's that, and that is 80, 88, 92, 94, 95. So I can check it. There we go. I've checked it. So I don't know which method I prefer. I mean, realistically, I suppose I'm quicker doing that. So maybe that is better because speed is the one that matters. But I'll probably still check it, especially if I had time at the end of an exam. So let's do another one. The next one is 127. No, it's not. It's B4. So B4. So that's 176. That's 180 because 16 times B is 176 and 4 is 4. So that's 180. So that might be more difficult, I suppose, to do it just by knowing the binary. You have to do 180. So maybe that is easier. So I'll put B4 back up. Oh, I've deleted B4, so I'll just have to rewrite. So let's go B4. So B is 11. So 11 in binary is 1011. I think. Yeah, double check. And then 4 is very easy. It is just 0100. And that is B4. And that is why people use hexadecimal. Because it's quite easy to convert back and forth between the numbers without doing it. And the reason that works is because this number, right, is worth 16 times this number. And if you think about it, this is worth 1, 2, 4, 8, 16, 32, oh god, I'm doing very small things here, 64 and 128. Right, now, this one is 16 and that's 1. So this one is worth 16 times that one. That's 32 and that's worth 2. 2 times 16 is 32. So you can see that each of these digits, this one is worth 16 times more than this one. And that's the same as, our math, but 10 more. So hopefully you can convert the last two to binary. Probably best to use this method here, but then I probably would check it after. So this number was supposed to be 180. So I'd then check that it's 128 plus 32 is 160, 176, 180. There you go. And also you can check each block because that should add up to 176 and that should add up to 4. So it's quite easy to work that out. Okay, off you go.